Hello. I'm going to uh, explain some. I'm going to talk about question 2 of homework 3. And before doing that, I need to clarify the inequality you have to know. You should have known. Like pretty obvious. Like put it this way. So think about this: a minus b squared, and then if you put it this way, this is correct, but if you use inequality like this, it is wrong. So even if you put absolute value here, also wrong because of this negative sign. So you have to make it positive. So I mean, what's correct is this one actually. You have to uh, bound bound the square to quadratic term using all the positive things, like here you have to use positive even if you have like negative here. So even if like actually the bound is the same no matter what you have. So even if you have a plus b squared or a minus b squared, the bound should be the same. It does not matter um, in the inequality. And by the way, just to give you a few tips on like leaks, you may want to check your toolbars here. So if you can change your toolbars, and this is just my setting, then you can check. Like you can see here, there are parentheses, and this is matrix, and this is like cases, and here you can see some, mathematical symbols. So you may use these guys uh, like on this panel. And also, just one common notation, but many of you did not know was, say, beta transpose. So the notation I use is I will use superscript, but superscript is Alt ME, but I use the shortcut. You can click this, but I know the shortcut. So Shift 6 is actually the shortcut, and I use this. So again, this is /TOP is my notation for transpose. So it is also okay even if you use T like this. That is not a problem. But in case if you wanted to use my notation but you couldn't find it, then it's this. And I believe you can find it here. Let me see. It should be somewhere here. Oh no. I don't remember where I found it. So if you look through these panels, somewhere there must be. I give up. Maybe not here. I could not find it. Oh, this one. Yeah, this is the notation I use for transposition. Okay, given this, many of you made a mistake in this inequality. So, and also, I made answer key, so you may use my answer key as a reference. But my algebra may be wrong. By the way, I had to give you this lemma first. So block diagonal is a matrix where you can write a matrix in this form. So it is matrix. It's not like A and B are also matrix, and this part is matrix of zeros. So it's like A and B 0, 0. So diagonal, but each diagonal term is a matrix. In this case, if A and B are strictly negative definite, so is M. Actually, you can extend it. If A and B are non-singular, then M is also non-singular. So this is a very nice property. And determinant of M is determinant of A times determinant of B. So block diagonal matrix has many nice properties. I'm not sure if you have learned it in an earlier class or not. If you haven't, it's a very important lemma from linear algebra. Will be very useful. And another thing I want to emphasize here, is this one. So when you calculate the log likelihood, what I do here is, like, by the way, just look at this definition. This is probability density function of y given x when the parameter value is theta, right? So simply, it is a distribution of y given x. You have to find that distribution, right? And that is given by the question. From the question, look at this. Epsilon is normally distributed given x. So conditional on x, epsilon is normally distributed with mean zero, variance gamma. And on top of that, you are adding x prime beta. By the way, when I say conditioning on x, that means x is already fixed. You are conditioning on, for example, like x equals to 0, or x equals to 10, x equals to a specific value. That's the idea of conditioning, right? So x prime beta, when you condition on x, x prime beta is constant. This is not random. So then, what you can think about it here is, epsilon was mean 0, but you are adding a constant, conditional on x, right? So conditional on x, y will be normally distributed with mean this x prime beta, comma variance gamma, right? Right? So you can think it this way. Suppose that, so epsilon, by the way, epsilon, the notation epsilon is like this. So I will compare this. If you simply use epsilon, the notations are different. No matter what you use, not a big problem. But let's use it. So if you assume that epsilon is mean zero normal distribution, and then if you add something, you know, if you add a constant, it will be normal distribution with mean of the constant, right? So using that idea, I wanted you to point this out. Y is conditional on x. Y is normally distributed with mean x prime beta and variance gamma. This is the key idea. So once you write this, by the way, in the homework, I give you the answer. I give you I already gave you almost everything. So I wanted you to write something like this, the main key idea. So algebra is just tedious. Algebra goes this way, and I wrote in detail to help you understand what this looks like. It is a vector, so it should look like this. I wanted to explain. Oh, it's a typo. Should be beta prime, right, like this. So it was slopey notation. So anyhow, and then another problem here. The order should be changed. But I understand it may be confusing. So many of you have done using scalar beta, but you have to say that. Just state that I'm assuming beta is one-dimensional. Otherwise, I don't know what you're doing. And for example, let's see your answers. Most of you have done pretty well. Let me see if there is anything I wanted to say about this. So here in this answer, so she said two-dimensional. That means already assumes beta is one-dimensional. That's okay, but had to say that, right? Assume beta is one-dimensional. Then this is right. And then transpose doesn't mean anything. Beta is one-dimensional, then X should be one-dimensional. So transpose is not an appropriate, like useless, unnecessary notation. So in that sense, that's a little bit inconsistency. And okay, so four-dimensional. We don't say a matrix is four-dimensional. You have to say 2 by 2 dimension. And again, if beta is one-dimensional, you don't need to put transpose, right? Oh, this notation is correct. This notation is correct. Like delta beta, delta gamma, and gamma beta. But when beta is a vector, the order is important to match the dimension. And let me see if there is any other comment on this. Oh, good job. So let's think about part B. B is, by the way, in part B and in part E, you are doing pretty much the same thing, but intentionally I made two different questions because I want you to see the difference between population maximization, which is an identification. It's purely theoretical argument. If you had an infinite number of observations, you can identify beta 0, true parameter, using as the unique maximizer. And here, but even in finite sample, still you can use the maximum as an estimator. So these two are related, but they are different. So you have to use the notation consistent with what you are dealing with. Okay, let me see. Here in this answer, second order condition, second derivative, okay, it's okay. Second derivative, but first problem is expectation is missing. Should have been an expectation here, and had to show that this is negatively definite, strictly negative definite. So there was no discussion about the second order condition. It is about second order condition. Second order condition is about like definiteness, positive or negative definiteness of the second derivative. So the discussion is incomplete. And here, in this answer, check uniqueness. Actually, the other way. So she said first order condition is uniqueness, and the second order condition is maximizer. But actually, the other way. In the first order condition, we are looking for where the derivative is flat. Derivative is 0, where the slope is 0. So when the slope is 0, it will be either minimum if the function looks like this, or maximum if the function looks like this. So first order condition will give you one potential minimum or maximum, right? And so it's and then in the second order condition, if the second order condition is positive definite, then the first order condition solution was minimum. And if it's globally strictly positive definite, then the first order condition solution was global unique minimum, right? So second order condition is about uniqueness and whether it is minimum or maximum, and the first order condition is to check to find the solution, right? Either maximum or minimum. So conceptually, kind of there was a misunderstanding what the first order condition is and the second order condition is. So I wanted to point that out. Okay. And from here, algebra mistake. I don't know. Or maybe you wanted to replace beta with something else, but without knowing beta, I believe it shouldn't be that difficult. I don't know where the problem started. Okay, so but it is not correct. The final answer is not correct. So compare with other answers for algebra. Okay, and let me see. Here in this answer, expectation should have been taken. So this is not correct because L is random, but on the right hand side, the expectation is taken. So the notation is not consistent. And again, post multiplication is different from pre-multiplication, so this is wrong. Again, expectation is not taken, and also expectation is missing here. So, and this notation is not common, so we had to say negative definite. Matrix is a negative definite. I see. So in this case, beta is one-dimensional, then it makes sense. Okay. Okay. And then part C, show that it is non-singular. And this is based on the lemma I showed you. So using the block diagonal form, then you can easily prove definiteness for each of them, which is pretty straightforward. Okay, let me see if there's anything I can say. Here, algebra mistake. First, you had to, expectation should be taken first and then multiply them. So expectation, what I'm saying here is expectation x times x is different from expectation x times expectation x. So this algebra mistake is made in this answer. Again, this is true only if x is one-dimensional. But consistently, beta was treated as if a matrix. So in that sense, need to state the assumption, right? If x is scalar, then this is correct. Otherwise, right, if m is a, if a 0 b 0, then determinant of m equals determinant of a times determinant of b. So you may use this result, block diagonal matrix result, to derive a similar form, but this is not correct without assuming x is scalar. Again, determinant of x is determinant of h is not this one. This is true only when x is scalar. Had to mention that. Have done. Okay. Part D. Calculating the variance. It is pretty just tedious algebra. Let me see. What you have to remember here is in the notation, theta 0 is used. Theta 0 is used. That means we are evaluating this function at the true parameter value. So the notation should be consistent. Like beta, so only when it equals to beta 0, then you can rewrite this to epsilon. So without beta 0, it may, if the beta is different from beta 0, y minus x prime beta could be different from epsilon, right? Epsilon is y minus x beta 0, right? That's one thing I had to notice. And here, I don't know, I don't understand what this meant. Covariance of this. This is a vector. If you take it as a vector, first, if it was a scalar, it does not make any sense. Scalar, when it is a scalar variable, you have to include another variable to calculate the covariance. So the notation is undefined if it was a scalar. If it was a vector, some people write covariance of a vector in the same way as a variance of a vector. So this is misleading. If you write this way, this equals to exactly the same thing like this. So these two are the same thing in the common notation. So something is missing. And this mistake is made in many answers. So I think you are sharing wrong answer. I understand, like I encourage discussion among you guys, but someone had to detect it, right? Wrong answer is going around, and here I don't understand where it's from. Like first, you had to explain why this is equal, why they are equal, and I don't know where this is coming from. So I have no idea. Here, kurtosis, we don't call this as the kurtosis. This is just the variance of this part, the variance of something, but we don't say kurtosis. Kurtosis is the fourth order. Fourth order moment is called kurtosis. That captures the thickness of the tail of the distribution. So just if you are not familiar with kurtosis, you can just Wikipedia it. There must be some simple explanation about kurtosis. This equality is not correct because kurtosis is misused. Similarly, skewness, I don't know what this meant. Skewness is 0 if the distribution is symmetric. So in this case, yes, normal distribution is symmetric, so skewness is 0. So the equality itself is correct, but it is not related to the answer. Here I don't understand how she got to this point. So there is no work considered here. Okay, that was D. And E, find a closed form solution. Closed form solution means is a solution like this. So we are solving for beta hat and gamma hat. So when I say a closed form solution, that means you have to write the solution like in this form. Beta hat equals something. Gamma hat equals something. So then you can just calculate the right hand side to calculate the estimator. So this is the closed form solution. And most of you have done a good job. It was the standard OLS solution. So I believe you are familiar with the algebra. Okay. Typo or algebra mistake. There should be another x here. And n is missing. N should be divided here. Algebra mistakes. Here, close in this answer, closed form solution, the word closed form solution is misunderstood. So written totally different argument is written here, but read other classmates' answers. And the next question, F. This is the example that I mentioned in class. I give you the answer. You have to show this result, and I give you a hint. So I gave you everything. You use Cauchy-Schwarz inequality to show this inequality. Then what you have to do is you have to show where this Cauchy-Schwarz inequality is used to derive this inequality, right? I understand it is simple, but you know that is the point. Otherwise, there is no point of answering to this question. Okay, so like first, it's a mistake. This is not a mistake. Okay, it's good job, but like, so where the Cauchy-Schwarz inequality is used. That's the key point of this question, but not explained. Just repeating, like just expansion of quadratic term and repeating the result I gave you in the question, saying the same thing I gave you in the hint, doesn't do any value added. There is no value added from the question. So, pointless. Like, okay, this is what I wanted. So you have to explain this part. You had to explain how Cauchy-Schwarz inequality can be used to obtain this result. Okay, that's what you had to write. It's not that long. As I said, just one line would be enough. That's the writing. Again here, Cauchy-Schwarz inequality is applied. It's more kind, but where? Employing the Cauchy-Schwarz inequality, this is not true. So this is example where Cauchy-Schwarz inequality is not correctly used. Cauchy-Schwarz inequality is applied here, not this step. So coming from here to here is not the inequality, but from here to here, this inequality is Cauchy-Schwarz inequality. This is correct, but this is not Cauchy-Schwarz inequality, right? So the name for this inequality is triangular inequality. So you can think that triangular inequality is about like addition or subtraction, and Cauchy-Schwarz inequality is about multiplication, like this. If the inside is plus or minus, then you may want to look at triangular inequality. But in this case, multiplication, then Cauchy-Schwarz. That's a simple tip when you prove something. Again, same can be said here. This is a mistake. This is not true. It is wrong. And second, due to Cauchy-Schwarz inequality. So how? Exactly this is the same inequality I gave you in the question. So these two lines are pointless. There is nothing more than the question, and this is maybe the only additional argument, but wrong. Again, I have to explain this part uses this inequality is from the Cauchy-Schwarz inequality. Actually, this is equality. There is this is equality, and again, this is typo. It is wrong and it should be positive. And this step requires Cauchy-Schwarz inequality. So have to state where the inequality is used. That's the point of the question, right? And so this is the annoying part. G. By the way, what I did not explain was the norm of the matrix. This is actually matrix, and this is the norm. And the norm of the matrix is not defined. I did not explain how that is defined, but what you just need to know is just to show the boundedness of the matrix, you can just show that each element of the matrix is bounded. That's enough. That's what I wanted. So if everything is bounded, of course, the whole matrix is bounded. That's what I wanted. And let's see. Again, negative sign should not be here because you used inequality. And this is not wrong. So the norm of a matrix can be defined in many different ways, but I don't know if there is a norm like this. Maximum norm, I don't know. I haven't seen it, but it is not the standard norm. So, but idea is the same. If the maximum is bounded, then this part is bounded. But this inequality is not correct. So this is my bad, like because I did not explain the norm of the matrix. And here he mentioned full rank, but it is not about full rank. It is more related to boundedness. So even if it does not have a full rank, still the matrix can be bounded. So this is coming from the assumption in the question, like this. So this assumption is different from the finite second order moment of x is not full rank assumption, but this is why this part is bounded. So that is, this is slightly different. This is not exactly correct. See, did well. Again, minus are all wrong. So, yeah, not bad. Like so, element by element inequality. So again, okay, this is a good example to compare what you have done. Earlier, some of you used inequality of a matrix to say strict negative definite or strict positive definite. So in this case, but in this case, the inequality is used to say element by element comparison. So this is smaller than this, and this is smaller than this, and this is smaller than this, like that. So that's why inequality is not used on matrix. It can be confusing. Sometimes it may be used for strict like negative definite, but other times it may imply element by element inequality. So you have to be clear what you are using, how you are using the inequality. So in this case, the approach is correct. And additionally, I had to show each element is finite. Suddenly get to the conclusion something is missing. And here, pretty short. The answer is correct, but more work should be done and read other answers. And here also negative sign is wrong and did good job for this. But this part, I don't know, it's not as simple as this, not as simple as this. So I don't understand how this algebra, this implies this. So it is our matrix. Okay, and finally the last question, excuse me, last question is to verify the conditions and derive the asymptotic variance. We have done almost everything. Like we checked all the conditions in an earlier part. By the way, what I had to point out here is it is only for beta, because I'm saying only for beta because gamma is a variance estimator and it is actually non-standard. You may use normal distribution asymptotic normality for the variance estimator, but that's not the standard way because it will follow F statistic or like F distribution or chi-square distribution. So that's why I just ask you to calculate for beta, and that is not a big difference. The only difference is the general, including beta, the variance matrix for the vector parameters can be written this way, and again block diagonal matrices. So you can just take this part to calculate the variance of beta, right? So this part, collecting these parts, and this is the asymptotic variance of beta, right? So that's how you can calculate the variance for beta. So in this case, I marked it because variance of gamma is not considered, and the notation is not correct then, right? But most of you have done like this is correct, and this part is the this part is the variance for beta. Okay. By the way, I don't know if this is correct or this is correct. I did not check algebra for this. So, but as I said, variance estimation is different story. So I did not do it. Um, uh, I do not understand because suddenly new notation coming up. Q had XX. I don't know if it was defined earlier, but I I don't know what that is. So maybe she's using another like textbook, but had to define this. I don't understand what these guys are, and then hard to tell. Uh, I don't know, like P. Maybe this is from the other question. So P squared. Something is not correct, but I cannot understand what is wrong. So the notation is undefined, and P is undefined here. So mostly did a good job. So here I am not certain what this is. Like and I am not certain what it is. What is omega and what is beta omega is. So it's hard to see. And like what is this small e? Expectation or epsilon? I cannot understand. So hard to say what was the mistake. Okay, so this example is more general framework. This is an example for the general asymptotic normality using specific example like normal distribution regression. Okay, just one like it was a lot of algebra, but I want you to be more careful in deriving the algebra. But what's more important than algebra is your idea, whether you understand what you are doing and what you are handling. Okay, I will see you in the next video.